Hi, my name is Steve Blyle and I'm a welder. Cutting torches like this are common in many types of shops and on construction sites. Besides welders, carpenters, plumbers, mechanics, auto body, and metal sculptors all find an occasion to use a cutting torch, and the better you learn to handle this, the more versatile it becomes. We'll be using a standard cutting torch. Pure oxygen is used for the cutting jet, and it's also mixed with either acetylene, propane, or some other commercial fuel gas to provide the preheat flames. An oxyacetylene mixture burns the hottest, somewhere around 5,800 degrees, and that's what we'll be using for our demonstrations. Many shops and individuals prefer propane because it's less expensive and available just about anywhere. Oxypropane burns around 5,300 degrees, which is plenty hot, but the rate of burn is slower, so it takes just a little longer to preheat before a cut. Either oxyacetylene or oxypropane works well for torch cutting. I'd like to describe how a cutting torch works, and this is as much of a chemistry lesson as it is cutting instruction. When oxygen comes in contact with metal, there's a chemical reaction called oxidation. Rusting is an example of a slow oxidation process. Oxygen molecules in the air combine with molecules of the metal to form an iron oxide, which is the rust. When metal is heated to cherry red, around 1800 degrees, and pure oxygen is introduced, the process speeds up and you get rapid oxidation, or combustion. That's what the cutting torch does. It actually burns the metal, producing a form of iron oxide we call slag. Now, the reason you can make a clean, controlled cut on carbon steel is that the oxides produced from this burning process have a lower melting temperature than the metal itself, and the force of the cutting jet blows the molten oxides through the cut before the metal can melt. On some metals like cast iron, stainless steel, and aluminum, the oxides that are created from burning have a higher melting temperature than the metal. So the metal itself is melting before the oxides can be blown away. You can get these metals hot enough just to melt all the way through, but it's difficult to make a clean cut. Now, before we get started, I need to mention safety. Everything we'll be working with is extremely hot, and the potential for injury to yourself, to other people, and to property is always present. In shops or construction sites, there's safety programs to help protect you. But safety is every individual's responsibility. You need to pay attention to what's going on around you and try to anticipate what will happen as a result of what you do. These torches are hot enough to burn just about anything, so when it's lit, be careful where you aim it. The molten slag blown from the cut can easily start a fire, so keep your work area clean. Move any flammable materials like solvents, paints, or fuels away from where you'll be cutting. Pay special attention to piles of sawdust, rags, or paper. These can start smoldering and you may not notice it. Always keep a fire extinguisher for all classes of fire handy and know how to use it. Frayed clothing will catch on fire, and avoid clothing made of synthetic materials. Synthetics melt to your skin if they're burned. Wear leather boots or some other protective footwear, and always wear safety glasses. It is totally uncomfortable to take a hot piece of metal in the eye, and it's not a whole lot more fun when the eye doctor has to dig it out. There isn't any way for anybody to cover every safety situation. Safety is an attitude. When you make working safely the #1 priority, you'll do fine. Okay, let's take a look at the equipment we'll be using.